Dear students, today we will discuss about combination of resistors. When the resistors are combined, then what will be the value of the effective resistance or the equivalent resistance? For which we will study what is series combination of resistors, what is parallel combination of resistors. First one is your series combination. You remember, it is the symbol of resistance, that is by zigzag line. It is resistance symbol. So here you see there are three resistors. They are combined end to end combination, that is the series combination, and one across the other, that is the parallel combination. So here you see, here the resistors are combined end to end. That means here the resistors are combined in series. So here we have three resistors of resistances R1, R2 and R3. They are in the series combination, and a source or a cell of EMF V is applied across them. So now we will find what is the effective resistance or the equivalent resistance. So now you see these resistances are combined in series so that the same current I flows through them. You see, the same current I flows through them. And you remember, from a battery or a cell, you know it is the positive terminal and it is the negative terminal. If I is the current coming from the positive terminal, then the same current I goes to the negative terminal. So now here you see the same current I flows through all the resistors, and you remember it is the connecting wire, and connecting wire, you remember it is represented by this line, and this line is the, you have to assume it is the ideal wire. And if it is ideal wire, then what is its resistance? Its resistance is 0. If its resistance is 0, then what is the potential drop? V is equal to IR. If R is equal to 0, then potential drop is 0. That means no potential drop occurs in this ideal wire. That means the potential at this point is same as this point, is same as at this point, is same as at this point, is same as at this point. Similarly, the potential at this point is same as at this point. That means if the wire is ideal, means by this straight line, then you can go to the, you can shift the point. So now potential at this point is same as potential at this point, and potential at this point is same as potential at this point. Now what is the potential difference between A and B? The potential difference between A and B is same as potential difference between the two terminals of the cell, that is V. So now what is the potential drop across R1? The potential at here will not be same as at here because it is the resistive wire, it has some resistance. So now what is the potential drop? The potential drop is V1, let it be. Similarly, potential drop in R2, that is V2. Similarly, potential drop across R3, that is V3. So can you say that V is equal to V1 plus V2 plus V3? The answer is yes. Why? Because the potential is a scalar quantity. You can add them algebraically. So V is equal to V1 plus V2 plus V3. Now what is V1? Potential drop across R1. The current is I, then it is IR1. Similarly, what is V2? V2 is IR2. And what is V3? That is IR3. You remember, when the resistors are combined in series, then current flowing through them is same, but the potential drop across them are different. So now you consider the net resistance of the combination is R equivalent. So now, what is the current flowing through R equivalent? That is I. And what is the potential difference across R equivalent? That is V. So now you can write V is equal to I into R equivalent. So now, from equation 1, in place of V, you will write I into R equivalent, and V1, that is IR1, V2, that is IR2, V3, that is IR3. So in all the terms you have I that can be cancelled. It will be R equivalent is equal to R1 plus R2 plus R3. It is the equivalent resistance when the resistors are combined in series. If there are n number of resistors, then it will continue up to Rn. So now here I can ask one question that you have n number of identical resistors of resistance are each. They are connected in series. What is the equivalent resistance? That is Rs is for series combination. Rs is the total resistance of the series combination or the equivalent resistance. That is R plus R plus R. How many times? That is n times. That equal to Nr. So now come to parallel combination. What is parallel combination? Just told that is one across the other. You have three resistors of resistances R1, R2, R3. You see, one end of all the resistors are connected to one point, let it be A, and other end of all resistors are connected to other point, let it be B. So now you can say R1, R2 and R3 are said to be in parallel combination, and the cell of EMF V is connected across them. So now to find what is the equivalent resistance, let I be the current flowing from positive terminal of the source, and you know the same current I will go to the negative terminal of the source, and you see this I current come to this point, and here the current I gets three branches. It is one branch, it is second branch, it is the third branch. So current will be splitted up. So through this branch, let the current be I1, and through this branch the current be I2, and through this branch the current be I3. Now what you got, when the resistors are in parallel combination, then different currents are flowing through them. When the current splits, then the branches are in parallel. So now you see, just told, if it is that straight line, it is not zigzag line, then the ideal, you have to assume it is the ideal wire, then there is no potential drop. That means the potential at this point is same as potential at this point is same as potential at this point. Similarly, potential at this point is same as potential at this point. Now what is the potential difference across R1? That is V. What is the potential difference across R2? V. Across R3? That is V. So you remember, when the resistors are in parallel combination, then potential drop across them is same, but current through them are different. So now come to net current I that splits into three parts, that is I1, I2, I3. So you can write I is equal to I1 plus I2 plus I3. It is your equation 1. Now, what is the potential difference across R1? That is V. So you can write I1, that is V by R1. Similarly, I2, that is V by R2. I3, V by R3. Let R equivalent is the equivalent resistance of the combination. So now you see the net resistance of the equivalent resistance is R EQ. What is the net current flowing through it? That is I. What is the potential difference? That is V. Therefore, I can write V by R equivalent. So you put these values in equation 1. So from equation 1, V by R equivalent is equal to V by R1 plus V by R2 plus V by R3, or 1 by R equivalent 1 by R1 plus 1 by R2 plus 1 by R3. That is the reciprocal of equivalent resistance in parallel combination is equal to sum of reciprocals of the individual resistances. If there are n number of resistors, it is continue up to Rn, 1 by Rn. So now come to one question. If you have n number of identical resistors of resistance are each are connected in parallel, then what is the equivalent resistance of the combination? So now you put, let Rp is the equivalent resistance of the combination, parallel combination of resistors. Then 1 by Rp is 1 by R plus 1 by R plus dot 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 n times, because you have n number of resistors, it is n by R, or Rp is equal to R by n. So you remember, if n number of identical resistors of resistance are each are connected in series, then equivalent resistance is NR. If they are connected in parallel, then equivalent resistance is R by N. So now come to one question. Suppose you have four resistors R1, R2, R3, R4. It is A point, B point, C point, D point. Let its resistance value is 1 ohm, 2 ohm, 3 ohm, 4 ohm. Now my question is, what is the equivalent resistance? What is the equivalent resistance between first bit A and B, second bit C and D, third bit A and C. So you remember, when the equivalent resistance is asked between any 2 points, then you have to assume a cell between these 2 points. So first one is between A and B, so you have to assume a battery or a cell between A and B. If it is positive terminal, if it is negative terminal, then if I is the current coming from the positive terminal, I is the current going to the negative terminal. So now here you get point A. At A, I is splitted off. Let it be I1, it is I2. So just told, if the current splits off, then the branches are in parallel. And in one branch, if the same current is flowing, then the resistors are in series. So now you see these two branches are in parallel. You see the same current I flows through R1 and R2. So R1 and R2 are in series. Here you see R3 and R4 are in series. Then the equivalent resistance of this is in parallel with the equivalent resistance of R3 and R4. So first bit between A and B, you see R1 is in series with R2. So RS1, that is R1 plus R2, that is 1 plus 2, that is 3 ohm. Similarly, R3 is in series with R4, then RS2, that is R3 plus R4, that is 3 plus 4, that is 7 ohm. Now, RS1 and RS2 are in parallel. So, RP means 1 by RP is equal to 1 by RS1 plus 1 by RS2. So you remember, if there are two resistors are in parallel, it is 1 by R1, 1 by R1 plus 1 by R2, then it is R1, R2, and above it is R2 plus R1, or you can write R is equal to R1, R2 by R1 plus R2. It is easy to write. So if there are two resistors are in parallel, if there are n resistors are in parallel, then you should not find like this, then you will use like this. So as there are two, so I can write directly Rp, that is Rs1 into Rs2 by Rs1 plus Rs2, that equal to 3 into 7 by 3 plus 7, that is 21 by 10, that is 2.1 ohm. Similarly, number 2, between C and D, the same concept you have to apply, that you have to assume a battery between C and D. If it is positive terminal, it is negative terminal, you will find if current I is coming from positive, then the same current I goes to the negative terminal. Here the current splits into two branches. Now R1 and R3 are in series, so the same current is flowing. So RS1 you can write 1 plus 3, that is 4 ohm. Similarly, R2 and R4 are in series, so RS2 is equal to 2 plus 4, that is 6 ohm. Now this RS1 and RS2 are in parallel, so equivalent resistance will be RS1 into RS2, 4 into 6 by 4 plus 6, that is 24 by 10, that is 2.4 ohm. So between A and C, you have to assume the battery between A and C. So now you see, if it is positive, if it is negative, then you will find if I is the current coming, it is I is the current going to the negative terminal, the current splits into two branches. Now you can say, you see here, these three resistors, through these three resistors, the same current is flowing. That is, these three resistors are in series, their equivalent resistance is in parallel with this. In this way, you will find the equivalent resistance. So, in the next class, we will discuss about combination of cells.